All right, so where we are now are T cell education. T cells, again, we're educating the thymus gland. All right, let's look at it from let's refresh what we have. A lymphocyte needs to know what to look for to fight and what not to fight. It wants to fight that's foreign and not fight your own cells. It wants to fight that's foreign and not your own cells. So going back to an earlier slide, lymphocytes must develop immunocompetence, that is, to look for the proper areas on the cell membrane of a cell and find if it's foreign, and attack that if it's foreign, but also develop self-tolerance in the educational so that you don't attack yourself. So these two. When we come to the T cells, positive selection is more of the immunocompetence in a way, and negative selection is where you don't fight yourself, and we'll see that. All right. So when a cell, a lymphocyte that has not been educated in the bone marrow enters the thymus, let's assume it gets accepted. All right. Now this is the difference between going to college and the way the thymus gland does it. The thymus gland gives the degrees up front. So the thymus gland gives the degrees up front, and then if you don't pass, it takes it away from you at the end. All right? And to go even a step further, with the thymus gland, if you don't graduate, it kills you off. So of 100 lymphocytes entering the thymic academy, only 2 will graduate. It has a 2% graduation. The other 98% pretty much are killed off before they leave the thymus gland. So the thymus gland gives you all of these credentials. Now it's going to give you, when you get in there, let's do a CD3. A CD3. A CD3 says you are a T cell. A CD3 is called a T cell receptor. A CD3 on the membrane, and you'll have thousands of these. On every cell, there's thousands of these receptors. A CD3 is a T cell receptor. It says you are a T cell. But there are different kinds of T cells. So it will also hand you a 4, a 8, or a 10. And then as you go through the education process, it will remove some of these. Like the 4 means you're a T helper. The 8, a T cytotoxic, and so forth. Okay. So the thymic education involves 2 processes, positive and negative selection. Now, while you're undergoing the education process, you don't want any foreign substances coming in. So therefore, we had a blood thymic. Just like you had a blood-brain barrier, there's a blood-thymic barrier. No foreign substances should get in while it's being educated. Because if a foreign substance got in, the T cell that's being educated might think that's part of you and ignore it. It might ignore it. And from that day forward, always ignore it. So you only want the cells of the thymus in there. All right. Let's start with positive selection. Positive selection is where the developing T cells, using their T cell receptors, look around on thymic cells that are there, cells of the thymus, and look for where to look for the proper name badge on a cell. The proper name badge on a cell. Because the cell has a lot of badges, but you're looking for the badges that say the proper badges for that. Now, cells will have badges to say your liver cell, kidney. That's not the ones. You're looking for those. That's why they call this an MHC restriction, to only look at that. Now, let me go to a picture I kind of put together. All right. On this gentleman here, he has a bunch of name badges. But you're trying to determine, is he part of the United States military, not a foreign military? So of all these badges, you have to be able to look and say, what badge says that you are USA? What badge says that you're United States among all these others? That's positive selection. You could look at all these others and still not know which one of these you should look at to say, are you part of the U.S.? Okay? This particular guy has a lot of badges too, but he doesn't have a U.S. deal. So the key is to be able to look at all of these, and that's MHC restriction. Restriction. Don't view anything else. Just look for what you got to look for. Okay? That's positive selection. When you see it, just lightly touch it. Don't hold on to it. Lightly touch it, just to be sure. Don't hold on to it. Because if you hold on to it, you're getting ready to attack. Negative selection is when you touch it and hold too tightly. Because then the assumption is that you're getting ready to attack. Those cells in the educational process that do that have flunked out. And they must be killed off. Because it is important for this to develop tolerance so that you don't grab the wrong thing. Okay? So the MHC restriction, I further clarify, good T lymphocytes would be restricted to only view antigens associated with an MHC1, MHC2. Remember, the MHCs are you. The major histocompatibility, that identifies you. That identifies you. You got MHC1, MHC2. If you're T helper cell, you should only view MHC2s. If you're T cytotoxic or any of the others, you should view MHC1s. So a T helper cell should view 2, cytotoxic should view 1. But that's the restriction process. When T cell enters the thymus, it receives many T cell receptors, 10,000 to 100,000. Now you wonder how they can fit. Well, see, cells are in 10 to the minus 6 meters. Molecules are 10 to the minus 9th. So a molecule compared to a cell is like one tree on the earth in the small world. So the T cell receptors are of different varieties. But you only view MHC1, MHC2. During the positive selection, only the variety of T cells having a T that can recognize our own isoantigens are the key ones. During positive T helper cells should be directed to only view MHC2 and the others MHC1 like the T cytotoxic. So you want to read on that. Then I go to negative selection. So when you first enter the thymus gland, remember, go back to the thymus gland, you enter from the outside, more of the cortex. Then you start going further in to the more middle area. And that's where you get into negative selection. Positive selection and negative. If it holds too tightly, then it's going to undergo apoptosis. So you have positive selection and negative selection. We have different types of T cells. The CD4 are the T helper, CD8 cytotoxic. So they do different roles. They still have a CD3, which means they're a T cell. Here's a little piece of the thymus. The outer cortex, when it first enters the outer cortex, is where you get positive selection. As it moves through into the more medullary area, that's where negative. And then if it passes both of those, it's gone. However, at this process of education is about 2 to 3 days, but only 2% of the 100 that came in, only 2 graduate. The others should undergo apoptosis, which is programmed cell death. Okay, so let's look at this. Here would be a T cell receptor on this T cell. Here's another cell with this MHC. In this case here, check this out. You see the T cell receptor, the CD3, doesn't fit quite right to look at the MHC. Now remember, the MHC also has something in its teeth. Remember, it has a peptide in its teeth. So in this case, this is fitting the MHC, but it's not locking to this self-peptide. Because see, that self-peptide is something that the cell made. So in this case, right here, it didn't fit right. In this case here, it did fit right and not locking, so that's positive selection. Let's look at this one. In this case, it's locking in on its teeth, getting ready to attack. So it didn't pass negative selection. But here, it did both, just like here. So therefore, this right here has passed the course and can exit. So that's how the T cells do it. Read on positive selection and negative selection. Here are B cells. Here are B cells. And I'm going to address them in the next video.